Hello, this is Mrs. Scarpel, and in this video I am going to review solving systems graphically as well as writing an inequality to represent a context. So we're going to begin with this system of equations where we have y equals 2/3 x plus 6 and y equals 2/3 x minus 3. The nice thing about this system is that both equations are in slope-intercept form. What that means is that each equation gives me the slope of the line as well as the intercept of the line. So let's start with the first equation. Y equals 2/3 x plus 6. That means its y-intercept is located at the point 0, 6. The 2/3 tells me that through that point is a line that goes up to and right 3. Or I can go backwards from my y-intercept and go down to left 3. And I can continue to do that to help me get points for my line. And then I'm going to graph a line through those points. So there's the first line. Second line, y equals 2/3 x minus 3 has a y-intercept at the point 0, -3. It also has a slope of 2/3. So from my y-intercept, I'm going to move up 2 units and to the right 3, up 2 and to the right 3. I could also go backwards from my y-intercept and go down to left 3 and graph a line through there. Now, if you remember, when we graph systems of equations, we want to look for a point where the two lines intersect. But in this case, both lines have the same slope. Because they have the same slope, these lines are considered to be parallel. And if they're parallel lines, that means they're never going to intersect. So, if you have a situation where you have the same slope in your two equations, or you can tell from looking at the graph that your lines are parallel lines, there is no solution. As long as the slopes are the same, there will be no solution. If the slopes are different, you will have one point where the two lines intersect, and therefore the solution would be that point of intersection. If we look at our next example, writing an inequality to represent the context, then we're being asked to list at least 5 solutions that fit the context. So here's our context. Fernando plans to donate at least $20 of the money he earned doing work for neighbors over the summer to 2 different fundraisers at his school. Well, because we have 2 different fundraisers, I need to use 2 different variables to represent the 2 fundraisers. So the amount of money that Fernando gives to fundraiser X and fundraiser Y has to be at least. That means it could be greater than or equal to $20. So our inequality is greater than or equal to $20. Now, some possible solutions, you just need to pick values of X and Y that will make this true. For example, I could choose 8 and 12. 8 plus 12 equals 20. Because we're including the 20, that point would work. Another possibility would be to use 15, 13. 15 plus 13 is 28, which is more than 20. We could use 12 and 12, giving each fundraiser the same amount. 12 plus 12 is 24. We could also give 5 and 30, because 5 plus 30 is 35, and that is more than 20. And one last possibility, I could give 10 and 15. 10 plus 15 is 25, which is more than 20. Now you could come up with 5 more answers that are different from these 5, but just keep in mind what we want are values of x and y, pairings of x and y that make this inequality true.